Welcome to SIM-PAC Live. I'm your host, Jeff Matthews, and today we have Kohn from Siemens Energy on the show. Murray is an expert in hydrogen solutions development and sustainable energy systems. Welcome, Murray. Thank you. Thank you for coming on the show.
No, thanks for having me, Jeff.
And we're going to talk about the wonderful world of hydrogen today. And Siemens Energy, to say you're big is a sort of an understatement. I think the market cap this morning was 25 billion euro. And you've got your fingers probably in every bit of the pie across the whole energy sector. And so it's natural that we will look to companies like yours to show us the way for the use of hydrogen in the future, its generation, its storage, the whole ecosystem of it. And could you just describe to us, what is that your role in that hydrogen value chain, and that'll give people an idea about how big this discussion can get.
Yeah, so I'm going to start with the overall picture of Siemens Energy. We're a global leader in energy technology, operating in 90 countries, a team of approximately 99,000, so almost 100,000 people globally, fully employed. And Siemens Energy, as you mentioned, operates across the whole energy landscape, from conventional to renewable power, from grid technologies to storage to electrifying complex industrial processes. And our mission is to support companies and countries with technology they need to reduce greenhouse gas emissions and make energy reliable, affordable, and more sustainable for the decades and centuries and generations to come. And then, I guess, going back to specifically on the hydrogen production, as you'll see in the image on the screen, the role in the value chain that Siemens Energy can provide, I guess a lot of people start talking about the electrolysis system, which is the newer, sexier technology that's still in its sort of development stage from a large industrial scale production that's been operating for decades. But outside of the electrolysis, there's a lot more, I guess, normal, less sexy, more boring technology that's required to also produce hydrogen in a renewable space, and derivatives downstream, then the transport via pipelines to port facilities for export projects. So there's a lot of other pieces of the puzzle outside of it. And I guess from a Siemens Energy perspective, starting with our Siemens Gamesa business unit, the focus on wind technology and wind power around the turbines to produce the renewable energy so that we can then produce green hydrogen. Then transmitting that renewable energy, we have our grid technologies business unit, which focus from HV-DC conversion systems to power transformers, HV switchgear, including the grid consulting, which is more the digital services, which is very much a growing industry with all the complexities created with adding a lot more renewable energy into the market, and being transmitted through existing and new transmission networks. There's a lot more complexity of getting that, and there's a lot of grid consulting that's been getting done, and that's very much a growing business globally as well. And sustainability, we're also looking at not just new technologies, but adapting existing technology. So we have a blue switchgear portfolio that uses clean air and vacuum switching technology instead of using what generally is the F gases, in particular SF6, which is 24-something thousand more times more climate hostile than the same
CO2.
amount of. So there's a lot of those sorts of adaptations that are using existing equipment but making it a lot more sustainable as well. And then obviously getting into the electrolysis, once we have the green electrons, they are then supplied to our current focus technology is proton exchange membrane, which is generally called PEM technology, which the current product is around the 17.5 megawatt ELISA P300 electrolysis system, produces up to 333 kilograms per hour of hydrogen. So further from that, there's also compression systems, which Siemens Energy have as well, so that we can combine a portfolio of individual equipment into an operating system that can be provided for developers to give the required pressure and purity of the for further processing or into hydrogen derivatives. And then we also have, outside of that, on the overall scheme, there's an electrification, automation, digitalisation technology with control systems, including digital services for also digital twin simulations that really work from assisting developers to optimize the complete project, including intermediate storage and all the different constraints that a project has, to develop the most optimized solution in a digital format long before we get into the detailed engineering design. And I guess to round off the whole value chain that Siemens Energy can provide is also on the gas turbine technology, which, again, a bit like the switchgear, is existing technology that's now being adapted to run up to 100% hydrogen. The goal is to have our entire fleet by 2030 suitable for 100% hydrogen, which many are already available to burn 75% hydrogen, and also many also in pilot plants and in the factories producing energy with 100% hydrogen burning. Biggest issue there is getting access to that hydrogen of green, and in Australia it's not such a big technology, but going forward in decades to come, it could potentially be something coming as well.
Yeah. So you've got this footprint, right across that energy and that value chain. It's quite a complex value chain. A lot of people don't think it's, how hard can it be? But even the existing fossil fuel value chain of energy is quite complex as well. So, it might be adding a little bit more, but it's still it's a complex business. Except one's 125 years old and the other one's just really emerging.
Yeah.
And what about the progression of projects? I mean, we see projects announced all the time, and we see amazing numbers attached to them in dollar figures, and amazing numbers attached to them in the amount of hydrogens produced. But we're also seeing that what's announced, what gets financed, and what actually gets built. It's a very different set of progression.
Yes, no, you said that perfectly, and I guess the image on the screen sort of shows it's a little bit dated. It was from December last year, but it's still quite a relevant picture of the global markets that we've got as we see it. So many projects, as you mentioned, announced, a lot of big numbers, big multi-gigawatt projects, some very aggressive timelines on these projects. What we see is, I guess, the technology provider, that a very small portion of those are proceeding into FEED, and then an even lesser amount going into the FID stage, so getting all the way to the actual financial decision. But what we have seen in the last 12 months, and seeing even more so in the last 6 months, is a lot more of these projects are getting into, there's a lot more projects within the FEED design, so there's a front-end engineering design. So that's where a project is becoming viable. Companies are spending considerable amounts of money, employing engineering consultants to do the detailed engineering to get the project towards FID. So that's a very good sign of the market slowly starting to progress. And then hopefully a lot more of those projects that are now getting into FEED will start getting into FID. And even in the last 2 to 3 months, we've seen quite a few projects, especially in Europe, ranging from 100 to up to 280 megawatts of projects that have since been announced recently in the last few weeks, even mostly based on German and European funding. But we've just been selected by EWE in Germany as a technology provider for electrolysis equipment, and there's, as I said, a few other 100 and 150 megawatt projects that have been announced within Europe as well, and many other projects are getting much closer to that point in time. So, and we're starting to see that a little bit more also in the Asia Pacific region. So we're seeing a lot more FEED projects, we're seeing a lot more getting closer, not of the same size and quantities that are in Europe, but it's at least a good sign of the market getting forward. Another interesting statistic on the image on the screen is also, as mentioned, the European projects are leading the way from the number of announcements in time. But there's also a lot more followed by North America, which has also slowed down a bit with elections and more political things. What's most interesting on that image is the hexagons on the side, where you'll see the Latin America, the Oceania, which is mostly Australia, Middle East, China have all increased significantly. And in comparison, India by far leads the way of the number of new announcements. So, and that's on the back of increased government support, which we're also seeing from Japan, Korea, Singapore, as well as Australia, with significant government support in hydrogen head start, hydrogen production tax. So we're seeing a lot more stimulus within the Asia Pacific region and in Australia as well, based on all these government support, which is what's, I guess, the catalyst for a lot of the projects in Europe as well. Taking a lot longer than a lot of people expected, but the reality is this is probably the right timeline for a lot of these projects to be developed. It does take time to build these projects, find the right offtakes, get the financial backing required to deliver the project.
Yes.
So it is good signs coming, but there's still a lot to go, I think.
Yes, and I think that's why just the natural timelines to build and consent and get things operational in industry, especially heavy industry, these are long timelines anyway. So when you see announcements that we're going to get X by 2030, and you sort of start to think about it. And there's a stat that came out from the IEA last year, and it was that the average across the OECD to consent and install one overhead transmission line, a single overhead transmission line, was 13 years, the average across the OECD. And, you know, we're now we're knocking on the door 2025, and you had 13 years just to consent one overhead cable.
Right.
And, you know, your 2030 targets start to go out the window really fast. So yes, it does take time. And in terms of the Asia Pacific region, do you see, we see Australia, and everyone says Australia is well positioned, almost unlimited renewable energy in the form of sun. And we see some of our Asian neighbours with densely populated areas and not so much renewable energy potential. And this trade and export, you know, and you get various people saying, well, it may never materialise, and other people saying, well, we should back this horse. Are you seeing, in terms of the countries being involved, talking to each other, what are you seeing, especially from a German-owned company?
Yeah, no, we do see a lot of interaction within the Asian countries. I mean, a lot of these countries are already, as you mentioned, importing natural gas, coal from the likes of Australia and other parts of Asia as well. So it's not an unusual thing for these countries to import their power generation fuels. And so it is and as you mentioned, a lot of these countries don't have the land mass or the renewable energy resources that Australia is abundant with. So it makes sense that they're now looking to parts of Australia, but not just Australia. And that's the risk that I guess we run within Australia. If we don't get into things quick enough, it could be other countries may take over as well. So there's a lot of other projects that we see being, I guess, focused on the Asia Pacific region in my role as well. We do see a lot of other countries getting in the line to export to the Japans and the Koreans, Singapore, these sorts of countries that are importing all their natural gas and coal for their power usage at the moment. So we do see, they have the history there already, and it's just building on those histories to start growing a hydrogen economy, because all these countries have quite a large government support to decarbonise their industries as well. So there's a lot of work in the background. We see a lot of Asia Pacific conferences with Japan Australia conference, or Korea and Australia, Singapore. There's a lot of those sorts of bilateral business conferences, and it's more about connecting people. We also have delegations even coming from the likes of Germany for the upcoming Asia Pacific hydrogen conference where they're bringing out a lot of off-takers from the likes of Germany and Europe to meet developers in Australia that could potentially export, because they don't want to be in the same position they were with Russia a few years ago, where they had a lot of reliance on one stream. They're also looking to expand into other parts of the world, including the likes of Australia and parts of Asia. So we do see a lot of interaction in the Asia Pacific, but also outside of that as well.
And for a company like yours, doing business in Australia, do you see any opportunity that once these projects start rolling out, for manufacturing to be reshored in Australia, or will a lot of this still be imported?
It depends on what type of manufacturing. So at the moment, from I guess the Siemens Energy perspective, we have our Berlin manufacturing facility and for the electrolyser stacks, which is, I guess, the heart of the electrolyser. But that is just the stack. To make an electrolysis system, you need all the electrical equipment, you need all the process piping and all of that, which currently is being done in our own facilities and third parties in Europe, because that's where the projects are. But the plan is to have a decentralized, what we call packaging arrangements, which could potentially be in parts of Asia Pacific, including Australia, as these projects develop and actually go to FID, and we've got a bit more of a throughput in the region. The plan is always to, I guess, decentralise like we have with all the other projects. So there is a potential for Australia. They do compete, obviously, with other parts of Asia, because all governments within the region are looking for local manufacture, as well as Australia. So sitting in Australia, I'd like to keep things here, but obviously we look at it from a more global perspective. But there's also a lot of, I guess, the oil and gas type scenarios where we've done a lot of oil and gas projects in Australia, and natural gas projects, LNG plants, things like this. A lot of those skills can be transitioned into hydrogen, because it's a very similar processing equipment, very similar technologies. A lot of the electrolysis is a little different, but all the other process technologies around moving the gas is very similar, if not the same. So we're seeing a lot more of that reskilling of people and upskilling to get there. So it's probably more from a personnel perspective, but there's definitely opportunity for some additional local manufacturing as the projects develop as well.
And can you share with us any projects you've got going on that are public here in Australia?
Yeah, so the one project we can mention public, which is part of the public arena, is the Edify Green Hydrogen project in Townsville, which is located in the Lansdowne Eco-Industrial Precinct. So on the screen, you'll see a bit of a snapshot of the image of the plant and also the location. So Edify Energy partnered with Siemens Energy to develop the hydrogen production facility, and quite some years ago, and a few years ago, we were selected as an eligible project under the German-Australian, what they call the Hydrogen Innovation and Technology Incubator, which is generally known as HyGate, which was funding from both the German and Australian government. We also have 2 universities from both Australia and 2 from Germany involved, because the idea is, while it's a domestic use project, the German interest is more to get the technology knowledge and application knowledge from these projects. There was 4 or 5 projects selected, and the Edify project was one of the main larger projects to be involved in that. And then further to that announcement, earlier this year, Edify Energy were also a successful applicant for the Townsville Regional Hydrogen Hubs funding from the federal government, which is accelerating the project now. We're working through the feed stage with Edify and our partners as well, which is accelerating the project to be shovel ready. The initial production facility is one electrolyser from our Siemens Energy portfolio, which is around 17.5 megawatts, as mentioned earlier. And the big, I guess, technology, not just the electrolysis, but it's also a behind-the-meter on-site solar facility. So it's really an island mode operation at relatively small scale, but still large enough to really understand how that operates in an island mode operation, And Edify and Siemens Energy have also partnered with Enscope, who's a local Australian EPC with a vast experience in natural gas facilities, and since 2016, diversifying into energy transition projects. And Siemens Energy have been collaborating since 2019 with Enscope on hydrogen projects in Australia, mostly in development stage. Not many have hit FID yet, but the Edify project is definitely one getting much closer. The end use, as mentioned, is more domestic, with local and regional offtakes within North Queensland in the industry and other parts. But this is stage one of a larger view. So Edify have development approval since 2021 for a gigawatt scale hydrogen facility, and there's also future phases of utility scale production capacity, more focused on export, but also to provide hydrogen and derivatives to the local industry as well. So, and then locationally, North Queensland is one of the most prime locations for renewable hydrogen, mainly due to the abundance of renewable energy resources available in the region. It's one of the better locations for wind and solar combined, and many different consultants have done reports and identified this as well, which is one of the reasons the Copper String project is now finally under construction. They finally started construction early this year as well, which is 840 kilometres of electricity transmission. And as you mentioned, it takes many, many years to just develop those sorts of things. That's been in the development stage for many, many years. But now the plan is to get that operational. I think this Copper String 2032 is their slogan on the website. But it's effectively connecting Townsville to Mount Isa, and then Mount Isa, and then the Townsville region to also into the natural electricity market as well, which can then feed all that renewable energy into the east coast of Australia.
And the Edify side, have you broken ground on it yet? Is it under construction?
No, not at this stage. It's still going through what we call the feed stage. So we're still doing the detailed engineering, and it's getting closer to FID sort of mid next year is the target at the moment. So we're getting much closer to that stage, and it's the with all the government support, and it doesn't come just with government support. It's with close collaboration with many stakeholders, mostly around the local communities and all the local infrastructure facilities like Townsville Port, all the local, regional and federal and also international governments with the German government as well, the universities as mentioned earlier, and many other supporting partners involved in the project to get this sort of hydrogen ecosystem in the regional communities such as Townsville up and running. And so Edify have been a front runner on the solar and battery installations in Australia and have quite a good record there as well. And we're looking to work with them to really solidify the hydrogen industry within Townsville as well.
So you talked about the domestic end use for this and other hydrogen projects. It's possibly one of the most controversial things about hydrogen globally. And I think there was there were early hydrogen fans like I was, thought that we were going to heat our homes and drive hydrogen fuel cell cars, and quickly when the economics of it, and especially as battery technology developed, and is really I was sort of a hydrogen fan before there were really had battery technology available, and that's sort of taken it over. And you look at it and you go, well, yeah, we're not going to have hydrogen fuel cell passenger cars, and we also need hydrogen's going to be so precious because we need it for so many industrial applications to decarbonise what we're currently doing, and to do things like green steel or even recycle aluminium, which is just hardly ever mentioned. We have to recycle millions of tonnes of that a year, and currently there's no way to do it without burning fossil fuels. So we're going to need every bit of hydrogen we can, and then and also you have got the aviation industry also thinking that they're going to go biofuels of some sort, but hydrogen's always going to be put in the mix of those biofuels. So up on this side, and where is the domestic stuff? You said there might be some industrial application. Where is it going? And what's your thoughts about end use for hydrogen?
Yeah, and I mean, in Australia, there is some small, from a chemical and industrial application, so smelters and things that you already mentioned, not as prevalent as, say, places like Germany or Europe, where a lot of the bigger plants are in those sorts of facilities. But what we have seen, and a few of the projects that are announced and one in construction, is from the ammonia side. Obviously, we have a few ammonia plants in Australia that are getting hydrogen from natural gas in their current form, which is defined as grey hydrogen. So Yarra in Western Australia, Yarra Fertilisers in Western Australia, they're obviously developing a project to supplement some of their grey hydrogen with green, as well as Orica working with Origin Energy in Newcastle to do a similar thing with their existing ammonia facility down there. So there's a lot of those sorts of existing industries, as you mentioned, that are using hydrogen that are being derived from natural gas that can be, I guess, displaced with renewable hydrogen that then decarbonises a fair portion of their operations. So that's I guess the one use. Ammonia is also something that everyone feels relatively comfortable with, depending on who you talk to. From a shipping perspective as well, it does get transported globally, not to the scale that some people are suggesting, but it's also an okay carrier for hydrogen itself. Cracking it at the other end and the efficiency losses and actual losses of the hydrogen is something that is still yet to be found if it's commercially viable. But there are people looking at burning ammonia and other things like this. There's a lot of other things that ammonia can be used for. And if it's green ammonia, then it's obviously a bit more of a renewable source of fuel. One of the other big things you already mentioned was more in the bucket of e-fuels, but also on more sustainable aviation fuel is becoming a bit more, but also e-methanol for shipping, which a few projects in Europe are working through. And a lot of countries are putting in mandates for a certain portion of sustainable aviation fuels must be used by a certain date, which is also driving a lot of these projects to have
Singapore has
off-takers because they need to do it. It's not a matter of whether they want to be greener or decarbonise. It's governments putting in place laws and mandates that mean to operate in that industry, you need to have a path to using sustainable aviation fuel, which then creates demand, which then creates the projects to fill that demand. So we see a lot more in that sense, and we're also seeing it's not the silver bullet that some people make out that hydrogen technically can do everything, but as you mentioned, it takes a lot of energy to create hydrogen. Best used where it's best used. So there's other biofuel projects and other electrification rather than using hydrogen. You can just do a re-electrification, like for commuter cars and things like this. The battery technology has gotten to a point, but there are certain things that just it's just not possible. So that's where hydrogen becomes a lot more viable. So as I said, the large chemical, but then the green steel and green iron is becoming a lot more of a topic, especially in Australia, given that we have the advantage of not just the renewable energy resources that Australia has to create the green renewable hydrogen, but also the abundance of material deposits that's currently being shipped overseas in its raw form.
Yes.
Some of that early stage steel making process can still be done in Australia. And I guess the thought pattern we see in a lot of the discussions around that is we're not trying to take over the China or German steel industry or anything like this. It's more just taking out that first one or two stages of the process and then shipping that product to the steel mills that already exist in those countries, not creating the steel itself in Australia, the end product, but at least the first few parts of that process in Australia to add some value in Australia so that we're not just shipping what we have over the years with coal and iron ore and all the other, I guess, raw minerals that we just send straight overseas for other countries.
Yes, it's madness to ship the iron ore and the hydrogen all the way to Germany just to put it together.
Exactly.
That's the energy and things like hydrogen are going to be so precious to us. We won't be able to just afford to burn transportation, and it's a difficult thing to transport anyway. So, so yes, we see that. So, and in terms of your role, I suppose you guys have got to be patient. I mean, is that a word? Because there's so much that hype, and there's so much expectation. There's so many deadlines in place of how we're going to decarbonise the world's industrial systems, and yet you've coming from this engineering perspective is we've actually got to scope this and build it, and that's a long runway anyway.
Yeah. I mean, and that's one of the beauties of being part of a company like Siemens Energy that has a lot more than just one or two specific products. It's the whole value chain, effectively, for a lot of things, not just in the hydrogen industry, but there's a lot more things that, it is a patient game. There's been many projects that many people would have thought would have happened by now that haven't. There's been a lot of delays, and this isn't just an Australian thing. There's a lot of people thought the US economy would be well and truly up and running in the hydrogen space. There's been very few projects in that space in the US. We're seeing a lot more interest from the likes of Middle East and some parts of Africa, as well as I said, a lot of other parts of Asia Pacific getting a lot more interested. So there is a progression, but it is a much of a patient waiting game to be with these developers for the long journey to develop these projects, because they do take time. These things don't happen within years; they take many years to get to construction, and even that's still a challenge in any sort of industry at the moment. With all the renewable energy that's being built globally, as well as a lot of the electrical componentries for data centers and all these other large electrifying uses that are being done, it's putting a very large strain on, say, from our perspective, on the grid technologies where they do the transformers and switchgear. A lot of that equipment is not so much long to manufacture, but long lead times, because the factories are literally full, and we're opening new factories for transformers in many countries just to keep up with the demand, just the global economy at the moment, which is a good sign that a lot of these other countries are also decarbonising, as is Australia with renewable energy. But obviously hydrogen is starting to get there, and hopefully in the next 12 to 18 months we'll see a lot more projects get through the gate in our region as well.
It's fantastic. Look, Murray, thank you for coming on the show. It's been enlightening. We'll stay in touch. We'll see you at some stage at another SIM-PAC Live event, and we'll get some updates on these. And best of luck. And thank you for coming and giving us some clarity over what you're doing. It's been very insightful.
No, thank you for having me, Jeff, and it's been a pleasure.